It's Wednesday the 10th of May, a couple of days before the third quarter moon. Weather has been very chancy. Been away for a while, so I haven't been able to do any astro. Gotten a lot of rain here. There's our pear tree, full bloom. Apple tree, not at all. The observatory is set up. I've got an observing list of random studies this evening before me. All I did was, once I set up the scope again, after returning from travels, all I did was reset the time on the scope to make it accurately track Greenwich Mean. And then I've done a synchronization. This is Regulus you're seeing here. It's drifted a little bit off center. I did a synchronization with Spica to the east and Regulus, well, more or less overhead, but to the western position. I believe Arcturus is now going to be visible tonight. I'll probably synchronize to that as well. Maybe we'll get a look at Messier 3, a very brilliant globular cluster. As you can tell, it's not sky dark, so we won't actually begin the evening's observations. We'll hold out for that in about a half an hour or so. It's about 8:45, and as with the summer season approaches, days will longen and nights will shorten, and it'll be late evenings out to get any significant amount of real-time observation done with the 6-inch SkyWatcher with the REV II real-time imaging system. Just by way of general interest, I bet you might like to see, even when the sky is visibly blue, how a globular cluster progresses in revelation as the sky darkens. You have to match the shutter speed. Right now it's 2 flood, which means roughly about, I think it's about a 1/15 of a second exposure time times 6. So we're running in the sub-1 total arc second cycles here for this 6 overlays of an image of M3. Sky is still visibly blue. Cluster is visible as discrete stars on the screen. Now you got to keep in mind M3 is a pretty brilliant cluster, probably the rival of M13 in terms of its star compactness. It's about 19 arc minutes in size. We're only seeing maybe right at this point the central 5 arc minutes or so. I have to hold the handheld camera in such a way that the dark bar of highest contrast is right along the edge of the cluster. But what we're going to do is, as it gets a little darker, I'll keep bumping up the shutter speed, and we'll get a sense of what effect that has, as well as sky darkness has on globular cluster presentation. M3. It's a little more than 10 minutes later, almost 9 o'clock. Sky is still visibly blue but darkening. You can now see, with the same settings of 2 flood, which actually is 1/25 of a second, I just checked it out, that there is a nebulous core to M3 plus maybe a sprinkling of 24 brightest stars. The cluster itself is about 6.5 magnitude, which means the brightest stars are about 12.5. As mentioned previously, M3 is a rival to M13 in terms of brilliance. Easily found, all you have to do is sweep between Cor Caroli and Arcturus, and it's about halfway in between, easily visible in a pair of binoculars. Stars begin to resolve with maybe a 3-inch telescope at about 75x. What I want to show you now is what happens as we progress through that. Okay. We progress through the exposure times. Standard flood, as you can see here, is a 50th of a second. That's 1 flood. Now notice, as I progress even to 120th of a second, you can still make out faintly at a 250th of a second times 6, keep in mind. The globular cluster is a faint nebulosity. Let's take a look as we go up. 120th of a second. You can see a sprinkling of stars, but that may just be pixelation on the screen of the nebulosity. 50th of a second, stars become distinct and obvious. 2 flood was our original view, and now we're seeing, as I mentioned before, 10 minutes later than the original look, we're now seeing the nebula's core. Whenever you're setting up settings for real-time imaging, you want to actually get the best aesthetics, but you don't want to have to be fiddling around with these parameters because you have to keep constantly taking it out of imaging mode to go into setup mode. So what I'm looking at here as we progress through the flood ratings is probably the best setups for globular clusters. Once again, keep in mind the sky is still visibly blue, which means sky dark is yet to arrive. When we get up to about 32nd, 32 flood, we start to overwhelm the screen with luminosity at this point. So we can say 16 flood is about as long an exposure time as you want before sky dark in order to get a reasonably aesthetic and attractive view of M3. Be back in another 15 minutes or so. Now almost 9:20. We've got a resplendent view of Messier 3 globular cluster. Packed with stars, high density. This is 16 flood. I'm going to push it up to about 32, and then we're going to go after a planetary nebula in Hydra. Because obviously bright studies, such as globulars, look best when they're not overexposed. Tonight we'll feature a few galaxies. We'll probably operate at 128 flood, which means about 9 seconds of total exposure time. So let's push it up to 32 flood. If I can reach at things here while holding the camera. 32 flood. And now we're getting somewhat overexposed. So at least for bright globular clusters, we want to stay in the 16 to 32 flood region. We could also play with the auto gain control. Right now it's set 1 click short of its highest setting, which is 44.8. I figured they came up with that setting because that's where image quality begins to degrade. So dropping it back 1 other additional setting is probably a good way to go as a normal setup. Let's check out that planetary and Hydra. Planetaries, by the way, are rarely resolvable as planetaries unless they're a lot larger than about 1 arc minute. This one is sub 1 arc minute, about 3/4. But let's move on from there. For the purposes of this exploration, we're going to assume that bright blob in the center of the screen is actually the planetary nebula. It's about the right size. The only real way to confirm it is to either use some kind of a nebula filter so that bright stars will lose their luminosity while the planetary itself will remain equally bright. But we're going to try an experiment where I reduce exposure time and see if we can maintain yes. It does seem to have a rather nebular characteristic, doesn't it? You can see it. That probably is the planetary nebula there. We're down to 2 flood. Stars are pinpricky on the screen. Now, I had to do an equatorial flip, by the way, to get to this position. Whereas that nebulosity there is pretty clearly nebulosity. And that's at 2 flood. It's a fairly bright planetary nebula, however, at about magnitude 8.5. 3242 in Hydra. Let's capture the data on this. NGC 3242, planetary nebula in Hydra, magnitude 8.6, 40 by 35 arc seconds. Central star is magnitude 12.3, 3,600 light years distant, and it's well below the celestial equator. And that long, wending constellation of Hydra, the sea serpent, and there's our image. Once again, note that I really had to back out on the exposure time to reveal the nebulosity of the planetary on the screen. Otherwise, it just looked like an overbright star. Okay, I've returned to Galaxy settings now. 128 flood 42 auto gain control. We're looking at, if we can see it, NGC 3109, the Galaxy in Hydra. It's fairly bright, 9.9, but also quite large, 19.7 by 3.4 arc minutes. A mere 3.9 million light years away, probably places it within the bounds of the local group. Very far south, minus 26 degrees. This is going to reminiscent of Barnard's galaxy. It may not be visible on the screen, but at least we'll get an image of the realm in which it might otherwise appear. It's also at a very difficult hand visual position for me. I'll sweep the screen a few times and we'll see if we make something out. There might be something there. Look, I'm looking and seeing something rather elongate. Remember, this is a 19.3 by 3.5 arc minutes, so it's presenting edgewise to us. Pretty much looks like there is something just sweeping in the direction my hand is sweeping now. That may very well be our galaxy in Hydra, kind of spectral and faint. But I can only see it on the handheld camera imaging screen. If so, pretty decent view. There we have it. Have a quick look at Messier 65, just to get a sense of the seeing conditions. Pretty decent. Very edge-on, slightly tilted edge-on Galaxy M65. It has a neighbor 66, and there's, I think it's 3569. I can't be sure. A very large galaxy presenting edge-on with lots of dark nebulosity, as large if not larger than Messier 32 in space. So there's our view of 65. Let's go to 66. Forming on the screen now is Messier 66. Not quite as intensely visible as 65 was, certainly smaller, more irregular in shape, and more obliquely presented. Decent view. Unfortunately, I do not remember, I don't have a chart here, the neighboring member, the NGC member of the trio, but this gives us something to compare to previous views. Messier 66. And the third member of the Leo trio is 3628. It should be formulating on the screen. Edge on with a dark bar, very expansive, some 13 arc minutes in length. At its distance, which is about 35 million light years and some 14 arc minutes in size, it is comparable, if not larger, than Messier 31. Not as intrinsically brilliant, however. It's got a lot of cold, dark material. I'll switch the camera around and see if that helps in terms of imaging it. Got a lot of cold, dark material yet to be turned into stars, although the core is very apparent in the extensions. A good look, attractive galaxy. Not quite the same, as beautiful intrinsically as 891 in Perseus in my estimation, but still an extraordinary galaxy. NGC 3521 is a galaxy in Leo, magnitude 9, fairly large, 11.5 by 4 arc minutes. It's a spiral with a large bar and a core. It's 28 million light years distant, probably about the size of our own Milky Way. This is what our Milky Way might look at it presented kind of obliquely. It's right on the Earth, pretty close to the Earth celestial equator. So you can imagine some distant intelligence turning a scope on our own Milky Way galaxy. Here's a nice little presentation of what they might see. And I will synchronize in this galaxy before treading the skyways for the next study. There's our look. Nice Milky Way sized galaxy presented somewhat obliquely. As you see, 3, 5, 2, 1. NGC 3607 is another galaxy in Leo, magnitude 9.9. Pretty much face on at 4.6 by 4 arc minutes. It's a spiral of a class O, which means it's right at the branch point. Not particularly large because it's 38 million light years distant. Our own galaxy would probably be about 6 arc minutes in size, and the Andromeda about 8 or 9. However, looking at the galaxy, you can see that it's pretty close as a class O galaxy. It's pretty close to being an elliptical. Fairly intense and brilliant. I wonder what the calculations would be on it for size and relative luminosity. Probably brighter than most galaxies, maybe a half magnitude or a full magnitude brighter than the Andromeda galaxy we calculate out at. But there's our look at NGC 3607. NGC 3344 is a galaxy in Leo Minor, magnitude 9.9, fairly large, 7.1 by 6.8 arc minutes, kind of a face-on spiral with a large bar and a core, also rung. At 23 million light years distant, it's probably about our own galaxy or slightly smaller in size. It's giving a nice view. I can see the ring-like aspect to it a little bit and some spiral-esque arms. Fairly attractive study, face on with spiralicity and a ring. NGC 3344. You're zooming in on you, kid. Once again, for the record, NGC 3938, a galaxy in Ursa Majoris, magnitude 10.4, roughly 5 by 5 arc minutes, face-on spiral with a core, 40 million light years distant, sub-average to super-dwarf sized. You can see the spiral arms on it, and I think we are getting full objective aperture sighting along the optical tube assembly. I think the lens is fully exposed to light from this galaxy 3938 and Ursa Majoris, the big bear. Wow. Clearly present spiral arms and bright core. Can you even tell what directions the spiral is in? It looks like the galaxy is rotating in the anti-clockwise direction with the spirals trailing off in the clockwise direction. Very, very nice. NGC 3938 is galaxy at Ursa Major. It's pretty much being partially blocked by the roof dry. Magnitude 10.4, 5.1 by 5 arc minutes, a spiral with a core. 40 million light years distant. It's kind of a sub-average to super dwarfish sized galaxy at that distance and apparent size. We'll have a sweep of the screen. I think I see the galaxy right down there at the bottom. I'm going to have to center it up so we get another view. But you can see the galaxy there with spiral arms. Wow, impressive. Especially given the fact that we're seeing some occultation by the roof of the objective of the telescope. Let me center that baby up. Our final study for the night, although we may return to M3, is NGC 4449, a galaxy in Canis Venatici, which shares the bright star Cor Caroli as part of an alignment to M3, along with Arcturus. Magnitude is 9.6, fairly large, 6.2 by 4.9 arc minutes, a mere 12.4 million light years distant, so it is a dwarfish galaxy. I think we may or may not be getting the full aperture of the scope, but the galaxy is extremely interesting. It actually looks like it might be kind of a merger. You can see a smallish core off in this direction, and you can actually see the core, the main part of the galaxy, although that could be a really brilliant H2 region that I'm referring to as the minor core. This baby's very irregular. There's nebulosity off in this direction here. There's a core there. There's a secondary core or an H2 region there, or maybe an assimilated neighboring galaxy. Very unusual morphology to this galaxy. Might bear some investigation. I'll leave a caption with this about this galaxy. It's clearly outside the realms of the local group, which only extends about 7 million light years across. So, but there is an awful lot of interesting texture and detail in galaxy NGC 4449 in Canis Venatici. We're getting what I might describe as the equivalent of an 18-inch scope view using real-time imaging. A real boost to the 6-inch aperture of the SkyWatcher. Wow, look at all that texture. Here's the data on Messier 3, globular cluster, and Canis Venatici, not Bootes. Magnitude 6.3, large, 18.6 arc minutes, 33.9 thousand light years distant, well north of the celestial equator. At 128 flood, you can see why it's considered to be 19 arc minutes in size. Clearly, stars are extending all the way out about 15 arc minutes here. Remember this cluster. You can see it's incredibly overexposed at this setting. The best views, which we will now explore a little bit before Carpe Noctem out. I will go ahead and get ready for, let's see, down here, there, and we'll go back. Shutter. Oh, that's AGC Max. Let's take a look at that for 1 second. Reduce the gain control. Wow. 12 decibels brought us back almost to the point of 2 flood, didn't it? Look at that. Haven't really played with the decibel setting before. Let's go back up to 42. Difficult manipulating this. Typically, globular clusters will start at about 1/50th of a second. Let's see what we get. Wow, I'm not seeing anything there. Did I push it out of view? 2 flood. 4, and it's starting to reveal itself. That's very peculiar because we were getting a better view before. 8. Maybe just my head position. position is off. It looks a lot better in the camera, handheld camera. 16. Once we get up to about 16 flood, we're starting to lose our resolution. I'm going to just assume for most globular clusters, 32 flood works pretty well, especially those 8th, 9th magnitude clusters. So there we have it. A little exploration of shutter settings and AGC, auto gain control. And to all, good night. Glad I was able to share some of the views of the night sky. It's been about 5 or 6 weeks before I had a chance to do this, and I hope you appreciated it as much as I. Carpe.